Hi everybody, today we're going to have a look at some coordinate geometry and see how we go with starting our linear algebra journey. So what does coordinate geometry do? It provides a link between geometry and algebra. It was originated by René Descartes, a French mathematician in the 17th century, and provides the basis of analytical geometry and is used in many branches of maths. So where's the starting point? Well, I suppose it starts with the Cartesian plane. It's a pair of axes. The horizontal axis is called the x-axis. The vertical axis is called the y-axis, and the point where they meet is called the origin. Typically, it's labelled with a point with the letter O. That's the origin there. And what we do then is we measure the distance from the origin in terms of the horizontal distance and then the vertical distance. And we record these in a thing called a coordinate. So, what does that look like? Well, say we wanted to define this point here on a surface. Imagine that you've got a rubber on a desk and you want to define mathematically where it is. Well, we could do that by declaring one corner of the desk the origin, and say here, and then measuring the distance from the origin horizontally and vertically, and putting those values into a coordinate. A coordinate is an ordered pair because the x part, the horizontal part, always comes first, and the y part, the vertical part, always comes second. So let's have a look at a case of that. Here we have a point A. It's sitting on our plane. Here's our flat surface. From the origin, the positive values go this way, and the positive values go that way on the vertical axes. The negative values go this way on the horizontal axis and this way on the negative axis. So if we were going to declare the point A, we would start at the origin, go across 3 units, because that's directly underneath the point, and then go up 2 units. And we would declare this point here, point 3, 2, with a bracket around it. It's not point 2, 3, because point 2, 3 would be up here. It's a completely different location. Now similarly, we can define point B by starting at the origin, going across -1, and then going down 2, which would get us to the point -1, -2. Now you can see that each time it's important that we start our thinking at the origin and then work horizontally first and then vertically. If we were going to name the 4 quadrants on a Cartesian plane, this is the first one where we have all positive values. The second one is where the y values are positive and the x values are negative. The third quadrant is where both are negative, and the fourth quadrant would be where the x values are positive and the y values are negative. A lot of the time we just work with the first quadrant because we're only working with positive values, and in our next series of slides we'll see how that could work with an example. So I hope that helps, and I'll see you in the next one. Thank you.